Good morning everyone. So welcome to my YouTube channel Math Sapna. So today we are going to see third practice set on functions of bounded variation. Till now, if you have not subscribed my YouTube channel, subscribe it immediately for such type of interesting topics. So let's start today's session now. The first question is fx is equal to x to the power alpha sin pi upon x to the power beta. If x belongs to 0 open 1 close and it is 0 if x is 0, alpha beta belongs to real number, alpha greater than 1, beta greater than 0, then f is function of bounded variation on 0, 1 if first option is alpha less than b, strictly less than b, beta is b is option alpha greater than equal to beta plus 1, and c is alpha is equal to beta, none of the above. The option is none of the above. Let's see its answer. Solution. Alpha greater than beta plus 1. I am taking this. Fx is equal to is x to the power alpha sin pi upon x to the power beta if x belongs to open 0, 1 close and it is 0 if x is 0. Okay. Now what is the derivative at 0? Limit x tends to 0 plus fx minus f0 upon x minus 0. What is this? This is equal to limit x tends to 0 plus x to the power alpha sin pi upon x to the power beta x. This is limit x to the power alpha minus sin x to the power beta. Okay, since alpha is greater than 0, this implies alpha minus 1 is greater than 0. So this and sin is bounded function, so this is 0. Okay. So derivative at 1 at 0 exists and it is 0. Now what about if x is not equal to 0? Then derivative of x is alpha x to the power alpha minus 1 sin pi upon x to the power beta. Okay. X to the power alpha into cos pi upon x to the power beta, and the differentiation of this is minus beta upon x to the power beta plus 1. So after solving it, you will get x to the power alpha minus 1 sin pi upon x to the power beta. Okay. And this is minus pi beta x to the power alpha minus beta minus 1 cos pi upon x to the power beta. Okay. But since we have taken the option alpha is greater than beta plus 1, so this implies alpha minus beta greater than 0. So this means this exists. Okay. And f dash x is less than equal to, this is bounded by 1 and this is bounded by 1. So this is alpha plus pi beta. Okay. Okay. So this implies f dash exists and bounded on 0, 1. Okay. So this implies f is function of bounded variation. If alpha is greater than beta plus 1. Okay. So option number B is correct. Now if you take alpha less than beta, So you see that if I am taking alpha less than beta, then you take this function. Alpha you take negative. Sorry. Okay. If we are taking alpha less than equal to beta, you take this partition Pn is equal to 0, 1 upon 2n plus 1, 1 upon 2n minus 1, 2 times to the power 1 upon beta, 2 times 1 upon, this is 2, and so on, 2 upon 5 to the power 1 upon beta, and 2 upon 3 to the power 1 upon beta. Then last is 1. So you can check that in this case SPN of F SPN okay of F tends to infinity as n tending to infinity. Okay? So this implies F is not function of bounded variation if alpha is less than equal to F. So neither option third is correct, neither one. So only option number B is correct. Okay. Second option is correct. So which of the following statement is not correct? Option number is sum of two functions of bounded variation is function of bounded variation. This is correct option, so it cannot be incorrect. So A is not the answer. Difference of two functions of bounded variation is function of bound. This is also correct, but in question it is asked not correct. So option number B is also exit from our answer. Option number C is product of two functions of bounded variation is function of bounded variation. Yes, it is also true. So it is also exit from our answer. So composition of two functions of bounded variation is a function of bounded variation. This is the option, okay, because this is not correct. Composition of two functions of bounded variation will not be a function of bounded variation. So let's see example why. I am taking this question. Fx is equal to x squared sine 1 upon x if okay, and this is 0 if x is 0. So f is function of bounded variation on closed interval 0 1. Now I am taking another function of bounded variation g. So gx I am taking this under root x on 0 1. G is function of bounded variation on 0 1. Now what is their composition? G of f. The composition is possible because the image of f is lies between lies in domain of G 0 1. Okay. So what is this? This is nothing but x sine 1 upon x. If x belongs to open 0 1, 0 is x is 0. Now what is this? I'm taking let's say h is equal to x sine 1 upon x. Okay. And 0 if x is equal to 0. Now see that, check that, observe that g of f is nothing but mod of f. Okay. Okay. And f is continuous. Okay. And we know one result. If f is function closed interval ab to r is continuous. Okay. Okay. If mod f is function of bounded variation, this implies f is function of bounded variation. I have done in second practice set. Now you see that now h is not function of bounded variation. H is not function of bounded variation. We have checked it. Okay, or we can check this is not function. Only pi. We have such examples, check x sine pi upon x. So there is no pi. Taking similar partition, we can show that this is not function of bounded variation. Okay, this is not function of bounded variation. So by this result, mod h cannot be function of bounded variation, because if h mod is function of bounded variation, h has to be function of bounded variation. But h is not function of bounded variation. This implies mod h is not function of bounded variation. But mod h is nothing but g of, so this implies g of f is not function of bounded variation. So which option is correct? So composition of two functions is a function of bounded variation. This is not correct. In question it is asked which option is not correct. So option number D is our answer. Okay. Now third question. F be a Lipschitz function with Lipschitz constant k. Then Bf need not be a Lipschitz function. Bf is also a Lipschitz function with, but Lipschitz constant may be other than k. Third option is Bf is also Lipschitz function with same Lipschitz constant k, none of the above. Let's check it. Okay. So f is Lipschitz constant. F is Lipschitz function. With Lipschitz constant A. So it means fx minus fy is less than k times x minus y. So what is, let's say P is partition of AB. Then what is SP? F, this is but but F is Lipschitz. So this is, so this is equal to k times summation xi minus xi minus 1, because xi is greater than xi minus 1. So I absolute will not affect. So after solving it, what you will get? Sorry, one thing. I made a mistake. Actually. So what is f is Lipschitz function? I am to check. Yes. So I am to, so that x is greater than y. So bfx minus bfy. What is this? Because bfx is monotonically increasing function. But this is nothing but bfax minus this is bfay. So what is this? bfxy. Sorry, yx. Yx. So this is what? Supremum of P belongs to rho xy SPF. Supremum of P. P is partition. A naught, X naught, like that. Okay. Xn is equal to B. And this belongs to rho xy. Okay. So what is this? SP is what? Summation I goes to 1 to n fxi minus 1. But here it is X. It is X. It is Y. So let me write it correctly. It is X naught, X1, Xn minus 1, Xn is equal to Y. So, but f is Lipschitz function. So, what you will get? This is supremum, this is greater than I goes to 1 to n k xi minus xi minus 1. Okay. So after solving, take since xi is greater than xi minus 1, so k will come out and I can write it xi minus xi minus 1. After solving it, what you will get? What you will get? Here it will be by x. Okay. By x is y x. This is x. Okay. What you will get? This is y x. This is y x. So after solving, what you will get? What is summation I goes to 1 to n xi minus 1. So this is x2 minus x1 minus x0 plus x2 minus x1 plus xn minus xn minus 1. So these things are being cancelled out. Okay, then finally it will be x minus y. So this is supremum rho E belongs to rho y x. This is y x minus y. But x minus y is fixed. So this is a times x minus y. So this implies bfx minus bfy is less than a times x minus. So this implies bf is Lipschitz. Is Lipschitz constant k. Okay. So if f is Lipschitz with Lipschitz constant k, bf is also Lipschitz with Lipschitz constant k. So option number C is correct. Okay. So let f closed interval a b to r be function of bounded variation and g be a function g closed interval c d to r g a Lipschitz function such that the range of a f function is contained in domain of g. Then g of is also function of bounded variation. G of is also is not a function of bounded variation. G not a function of bounded variation, none of the above. Okay. Let's see its solution. It is given that f closed interval a b to r is a function of bounded variation. And g closed interval c d to r is a Lipschitz function. and the range of range of function f is containing CD. The composition is well defined. Composition is well defined. Okay. Now we have to show that g of f is function of boundary. It will happen. How? Let p is equal to be a partition of AB. Okay. Then what will happen? What is SP G of F? Okay. Now we know that G is Lipschitz. No. G is Lipschitz. So there exists a greater than 0 such that gx minus gy is less than k times x minus y. Okay. So what does it mean? It means I goes to 1 to n k times fxi minus fxi minus 1. This is k times summation I goes to 1 to n fxi minus fxi minus 1. Now what is this? This is SP of f. This is k times SP of f. But SP of f, because f is function of bounded one, this will be less than this. So this implies SP of g of f is less than k times. Okay. So this implies supremum, this is finite. P belongs to row A, B, S, P, G of F, finite. This implies supremum S, P, G of F, P belongs to row A, B, exists in R. So this implies G of F is function of bounded variation. Okay. From here we can conclude that the variation of G of F is less than A times variation of F. Ultimately, G of F is function of bounded variation. So we have to click that option. So G of F is function of bounded variation. G of F is not a function of bounded variation. This is not correct. G is not a function of bounded variation. G is a Lipschitz function. Every Lipschitz function is a function of bounded variation. So it cannot be function of bounded variation. It is G is function of bounded variation. So option number C is not correct. None of the above is automatically is not correct. Okay. Now move to last question. F be a function of bounded variation. You are taking p greater than equal to less than infinity. Then mod f to the power p is not a function of bounded variation. Second option is mod of f to the power p is a function of bounded variation. C is 1 upon f is not a function of bounded variation. Both B and C are correct. Option number C is 1 upon f is function of bounded variation. Both both B and C are correct. Okay. Okay. So let's correct it. Okay. This is A here. Both A and C. This is A. Okay. So let's check it. Solution. Now you see that F close interval AB to R is a function of bounded variation. This implies so mod F is also function of bounded variation. Function of bounded variation. Now, now what is I am considering x to the power gx is equal to x to the power p function from closed interval CD to R, where C is non-negative and D is greater than C. Then you see that x to the power p is a Lipschitz function. G is Lipschitz function. G is Lipschitz function. Why? Because what is the derivative of gx? It is p to the power x to the power p minus 1. So this implies derivative of gx is less than p x to the power p minus 1. Put m naught is equal to max of C and D. Sorry, we can go directly. So this is less than p d to the power p minus 1. But this is finite because p is fixed. So G dash exists and is bounded. So what does it mean? It means that G dash exists and is bounded. What does it mean? G dash is, sorry, G is Lipschitz function. G is a Lipschitz function. So what is the Lipschitz function? Now what is the composition? Now what is the composition of G of F? This is nothing but the power P, where F function of bounded variation and what is G? G is Lipschitz function. Lipschitz function. By question 4. By question 4. By question 4. Question 4. We have G of f is function of bounded variation. So this implies mod f to the power p is a function of bounded variation. Okay. So which option is correct? Let's see. Mod f to the power p is a function of bounded variation. This is not correct. 1 upon f is not function of bounded variation. Why? Because you can take a function of bounded variation, bounded variation, fx is equal to minus 1, minus 1. Sorry, you can take this function. Fx is equal to 1 upon x on the open on the close minus 1 to 0 open, and it is 1 if x is equal to 0. So this is function of variation 1 upon f. 1 upon f is unbounded function. Then 1 upon f is not a function of bounded variation. You can take this function. Take fx is equal to 1 upon f if x belongs to 0 if x is equal to 0. This is f is function of you take this function. This is x and this is 1. F is function of this is f is function of bounded variation, because this is monotonically increasing function. Okay. But 1 upon f, what is this? 1 upon f is this function is 1 upon f if x is belongs to and 1 if x is. So 1 upon f is this is unbounded function. So this unbounded function cannot be function of bounded variation, because every function of bounded variation is bounded. So this implies 1 upon f is not function of bounded variation. So option number C is need not be correct. So option number C is not correct. Okay. So option number C is not correct. So option number B is correct. So option number A and C need not be correct. So that is why D cannot be correct. So it is A. Option A is there. Okay. So option number B is correct. So today's session up to this, if you have any problem related to this, you can comment me on my YouTube channel. Like, share, comment and subscribe my YouTube channel. Thank you very much for today's session. Thank you very much. We will see you in next session. Thank you very much.